Let's talk about average rate of change of a function now. The average rate of change between any 2 points, x1, f of x1, and x2, f of x2, is the slope of the line through the 2 points. The line through these 2 points is called the secant line. So average rate of change, I often abbreviate that as the AROC, is equal to f of x2 minus f of x1, all divided by x2 minus x1. Now, do not overcomplicate this equation. What are you actually finding? You are finding slope. Notice this is y2 minus y1 divided by x2 minus x1. All right, average rate of change, you are just finding the slope between the 2 points. And that line between those 2 points is called the secant line. Notice any function can have any number of secant lines. These are just an example of a few. All right, here I have a line that passes through these 2 points. That would be considered a secant line. All right, here I have another line that passes through these 2 points on my curve. That would be another secant line. All right, here in purple, I have another line that passes through these 2 points. That would also be considered a third secant line. All right, your graph can have an infinite number of secant lines, but you will be given this particular points that apply in each problem. All right, again, when you see the words average rate of change, think about the slope of the secant line, m secant, and keep it simple. F of x2 minus f of x1 divided by x2 minus x1. That's the same thing as y2 minus y1 over x2 minus x1, delta y over delta x. All you are doing is finding the slope between 2 points. So, find the average rate of change of f of x from x equals -1 to x equals 3. Notice here we have our function f of x is equal to x squared minus 2x. Well, what we are trying to find is the slope on this interval from x equals -1 to x equals 3. And in order to find the slope, I just have to have 2 points. Now, we are given 2 x coordinates. How would you find the corresponding y coordinates? Well, you would simply plug them into the function. Again, notice that plugging in -1 is going to give out the corresponding y value. Plugging in positive 3 will give out the corresponding y value associated with x equals 3. So our average rate of change would be f of 3 minus f of -1 divided by 3 minus a -1. Again, this is y2 minus y1 divided by x2 minus x1. And here are our 2 points. So when I plug in 3, notice there's my point associated with 3, and there is my point associated with x equals -1. Plugging in 3 for x gives me 3 for y. And actually plugging in -1 for x gives me out 3 for y, leaving me with 3 minus 3 divided by 4. Well, simplifying that down, 3 minus 3 is equal to 0 divided by 4 gives me 0 for my final answer. The average rate of change on the interval from x equals -1 to x equals 3 is equal to 0. And hopefully that makes sense. Here is our secant line, okay? And the slope of that secant line is 0. Okay, so let's take the same function here, f of x equals x squared minus 2x, and let's find the average rate of change now from x equals -4. All right, that's going to be right here, and x equals +4. Well, according to our average rate of change equation, this means f of 4 minus f of -4 divided by 4 minus a -4. y2 minus y1 divided by x2 minus x1. So let's plug in and evaluate f of 4. Well, here I have my value of 4. Notice that the corresponding y value is going to be 8. Plugging that in, 4 squared is 16, minus 2 times 4, 16 minus 8. Again, we can verify that as being 4, 8. There we have that point. Similarly, we could plug in negative 4. Notice negative 4 squared is 16 minus 2 times negative 4. Negative 4 squared is 16. Negative 2 times negative 4, that's going to be a plus 8. 16 plus 8 leaves us with 24. Here we have the ordered pair, negative 4, 24. So, again, all we are doing is finding the slope between those 2 points. It's y2 minus y1 over x2 minus x1. 8 minus 24 divided by 4 minus a negative 4 gives us 8. Now, 8 minus 24, that's going to give us a negative 16 divided by 8 gives us negative 2. And notice, what did we just find? We just found the slope of this secant line, the line crossing through these 2 points. And yes, we can verify. What does our slope do? Goes down to and over 1, right? Down to and over 1. Notice the scaling might look a little bit off. I have increments of 1 along the x-axis and increments of 4 on the y-axis. But the slope definitely is negative 2. Let's take a look at an applied problem here. A race car accelerates from the starting line of a straight track. The distance from the starting line is given by the function s of t is equal to 20t to the 3 halves, where s is measured in feet and t is measured in seconds. Find the average rate of change from t equals 4 to t equals 9. Include units with your answer. What do the results mean? All right, so we are trying to find the slope between the 2 points, one where t is equal to 4 and the other where t is equal to 9. Well, we have the x-coordinates. We need to plug in those x-coordinates to get the y-coordinates. My average rate of change would be s of 9 minus s of 4 divided by 9 minus 4. Again, you plug in an x value into the function, it gives you out the corresponding y. y2 minus y1 over x2 minus x1. Well, when we plug in 9 into our function, evaluate s of 9, we get 540 feet. Remember, s is being measured in feet. 540 feet. When I plug in 4 into my function, we get out 160 feet. So this becomes 540 feet minus 160 feet divided by 9 seconds. Again, remember, t is being measured in seconds here. This is 9 seconds minus 4 seconds. Simplifying this down leaves us with our final answer of 76 feet per second. 76 is the slope of our secant line. Now, one of the cool things to recognize here is that in math, we can actually plug in units into our equations, and it will tell us what the units of our answer is going to be. Notice in this case, we had feet in the numerator of this fraction, and we had seconds in the denominator of this fraction, which left us with feet per second as the unit of measure for our final answer. What do these results mean? Well, hopefully you recognize feet per second. Okay, that is a common way of measuring average speed. What we have just found, well, it's a common way of measuring speed. What we have just found, because this is the average rate of change, okay, because this is the average rate of change, this means that this is the average speed, or the average velocity in this case, of our car from t equals 4 to t equals 9 seconds. Okay, there we have it. A nice little application of average rate of change. Don't overcomplicate it though. All you are doing is finding the slope between 2 points.